Hi, I'm Carl Franklin. In this episode of Blazor Train, I'm talking with Daniel Roth from the ASP.NET Core team about why you should upgrade your Blazor applications to .NET 10. There are so many improvements in the areas of performance, reliability, scalability, validation, navigation, and a whole handful of what Dan calls quality of life improvements. So rather than go on with the blah-de-blah, let's get to my interview with Mr. Roth right now, right here on Blazor Train. Blazor Train! It's my pleasure to introduce and welcome back to Blazor Train, Daniel Roth from Microsoft. Daniel, how are you?
I'm doing great, Carl. It's great to be back on Blazor Train.
Yeah, it's good to have you back. I haven't done a Blazor Train episode for a long time, mostly because, there's new stuff, but a lot of the core stuff we've already covered, and it's just a matter of updating and upgrading and talking about what's new. But I think, since November, it's about time to talk about what's new in Blazor and .NET 10. But also, I want this to be a guide to why you should upgrade, right? Why you should be on .NET 10 versus 9, even going all the way back to 6. And there's a README in the repo that will point people to that sort of makes those arguments all the way back to .NET 6, why you should now be on .NET 10. So let's start with the obvious stuff. Take it away. Why .NET 10?
Well, it's because it's the best .NET release ever, of course, Carl. It's the fastest. It's
you like that meatball?
Most feature rich. Going back to .NET 6, of course, it's important to recognize that if you're going back that far, those releases aren't even technically in support anymore. So if you're really back on .NET 6 or .NET 7, you really should upgrade just for the sake of security, making sure you're getting the latest security patches, that you're on a supported framework. And we try really hard to keep our .NET versions backwards compatible. So upgrading from 6 to 7, 7 to 8, hopefully that is not a painful experience. For the most part, you should just be able to update your target framework moniker to the right new .NET version, update your packages, and you're good to go. There's actually even some AI-based tooling that can help with that. GitHub Copilot has an app modernization feature. Now that's actually part of Visual Studio, where you can just right click on your solution, your projects, and say, please modernize my solution, upgrade it to the latest .NET version. And it will even do fancy things like look at your package versions and reconcile which versions you're depending on and which ones have been updated to support .NET 10 and those types of things. So it's easier than ever before.
It's very slick. I live in the GitHub Copilot CLI these days, and I just tell it to go do my bidding, on top of PowerShell. And it writes PowerShell scripts and does amazing things.
Yeah. I mean, the app modernization tooling is even more specific and refined than just going to general. I mean, using GitHub Copilot, you can get really far with this. And for many cases, I'm sure it would work just on its own. But there is a GitHub Copilot app modernization gesture that's specifically been fed with a bunch of context and guidance and access to breaking change documentation. So it can help if there are cases where your code's been impacted by breaking changes from one version to the next, which hopefully is very rare, but sometimes does happen, that the tooling can help with adjusting with that. So it's easier to upgrade from one .NET version to the next now, I think, than it's ever been. And so hopefully the friction is low and the benefits are huge. .NET 10 is a big release, lots of new functionality. I don't know if you've seen the latest Stephen Tobe tome of performance he publishes every year, but it's hundreds of pages of long of runtime performance improvements that have been done in this release. And that's just the bottom of the stack. We have other performance improvements up the stack, lots of new features. This is a fantastic .NET release, and it's long-term support. So once you're on it, you're also now good for a good 3 years, which is really useful as well.
So and the thing is that every version of .NET has increased performance gains. But let's just talk about 9 to 10. What's the perf story there?
So there's just a bunch of stuff. So the runtime performance has gotten quite a bit better. So the JIT is much smarter in terms of it handles a bunch of scenarios. There's a bunch of hardware accelerations that are specifically lit up in .NET 10. Native AOT compiled code has been optimized quite a bit in .NET 10. how the stack allocations get handled in 10 is way better. There's actually a really awesome .NET Conf session from Stephen Tobe where he goes through a bunch of these benchmarks and shows like the code on .NET 8 or .NET 9, .NET 10, and you can just watch the performance numbers increase and the stack allocations just shrink in some cases to like nothing, and it's just great to see that. And those low-level performance improvements, of course, accrue to basically everyone. Like those are, things that affect like strings and, very cross-cutting related optimizations. Then you get into like Asmik Core and Blazor.
Well, let me go back to the stack allocations for a minute, because people may kind of know what that means, but not really what it means. What it really means is that you're not putting more objects on the garbage collector, right? And so you're not applying more memory pressure when you allocate and deallocate objects when they go out of scope, right?
Yeah.
And that's the basic problem with, not problem, but it's the nature of the managed runtime, that things go out of scope, they go in the garbage collector, and that creates memory pressure. And at a certain point, GC collect happens, and then you may find a little pause or something like that. But the whole goal is to shrink those and to minimize those allocations.
Exactly. And so in the runtime, we'll just do a bunch more of that in a much more intelligent way in .NET 10 for you than it ever has before. So a lot of the performance are in that bucket, but there are many others. Like there are also framework specific improvements in Asmik Core for like how we handle JSON data. There's also improvements in the Blazor WebAssembly runtime. The native AOT based compiled code is significantly faster at runtime in .NET 10, as is the JITterpreter based runtime. You just get better runtime performance execution out of the .NET WebAssembly runtime in .NET 10 than you did previously. So your components should render faster. If you're doing CPU intensive work streams like processing JSON files and that type of stuff, that code will execute faster in .NET 10.
I like that because you don't actually have to do anything. You just upgrade to .NET 10 and you get all this great stuff. Let's talk about Blazor Server. There's some new features in Blazor Server, and one in particular that really warms my heart, which is circuit state persistence.
Oh yeah.
Talk about that.
This is great. Okay, so I think it helps to remind everyone a little bit about how Blazor Server works. Like Blazor Server is a stateful programming model. You have a connection with the browser, and then you're maintaining some state on the server to make the app run. Like it's basically keeping track of all your components server side. And as UI events occur, those get sent to the server so the server can react to them. The components re-render. It figures out what needs to be updated in the DOM, and it sends those DOM diffs back down to the browser to have them be applied. But all that state about what's happening with the components is being kept in memory on the server. And if anything happens to that state, that can be problematic for the end user experience. And also it can be a scalability concern because you're managing all that state in memory. You're basically paying with your server resources to run the application. So some scenarios that are common is like, let's say the user gets disconnected somehow from the server. If the network goes down, like maybe they're on go through a tunnel while they're in the subway or something like that. If they lose the connection to the server, Blazor still has that state in memory, and it's that state's called a circuit,
right? And
it will have to decide what to do with that state. And by default, Blazor Server will hold on to that state for a little while, like about, I think 3 minutes is the default timeout. And then once that time is gone, this Blazor Server will decide, I guess that user's gone, so I'll just evict this circuit state. I'll get rid of this, free up those resources so I don't just have them parked there on my server. And the problem with that is that the user then comes back, say 5 minutes later or 10 minutes later, then they find that anything they were doing in the app is now gone. The app will, sort of refresh and basically start anew and create a new circuit, but whatever state you had in your previous circuit won't be there anymore unless the app did something to save that state and resurrect it in some way. So what we've done in 10 is first of all, we added a declarative model, like an attribute-based model, where you can say, this is the interesting state on my components. This is the stuff that I might want to save if you're going to persist the state of the circuit at any point in time.
Yeah, and I've taught my followers for years that we should probably just have one kind of app state component that has all the properties of things that we want to save on it. Not that it's going to do anything. It's not going to execute any code. It's just there for state. And it should be serializable, and we should be able to load and save that at will.
That's a great point. Like the attribute model accommodates for that. Like it doesn't just have to be like properties on your component that you're persisting. You can have a service that's in the dependency injection container that also has these attributes, and that will be persisted too. We support that as well. Wow. So you have a really simple way of saying what state is important, that if you want to save it, what it should be. So it's not just like, we don't just save everything. It's an explicit model, so you can control how big that state is and make sure you don't save ridiculous amounts of stuff. And then in a couple of cases, Blazor will automatically persist that state for you. So in that disconnected scenario that I described, where you lost the network connection and Blazor's like, oh no, I've got this circuit and I don't know what to do with it. It will now, after that 3-minute timeout, it will automatically persist the state of that circuit before evicting it. Then when the user comes back, that state can then be resurrected. It can be reloaded from the persisted store. By default, it will just persist it actually in memory, just using like the in-memory cache abstraction in ASP.NET Core. But if you wire up a distributed cache, like the hybrid cache abstraction, it will use that and it'll store it to like a distributed cache abstraction. So that gives you a much more resilient way of like making sure the user's circuit state, their session, if I guess effectively, doesn't get lost. So they get a much better connected experience.
Yeah, that's great.
There's also a scalability improvement that happens as well. Well,
let's go back to that, because I remember, in previous versions of Blazor, if you were disconnected and you came back to it, you would get what I called the pale white screen of death, right?
Right.
It was you were done, and it was very off-putting for the user. So, and this isn't an easy problem to solve. And we've been solving it just by doing these things manually. And I remember you reached out to me, I don't know, a year or two ago and said, we're thinking about doing something like this, and how do you do it, right? And so you've been talking to the community about how to persist the state. And I'm just really, really happy that it's baked in now. And all I have to do is decorate some things with attributes, and I don't have to worry about it.
Yep. That's the model.
It's great.
And so that will happen automatically on disconnect. There are other cases where you might want to basically pause the circuit, basically say, you know what, I don't think the user is really using this right now. Maybe they actually are still connected, but they left the browser open and then they went to lunch. So now you have an active connection with the server and circuit state being held in memory, but the user's not actually doing anything with that circuit. Like maybe they've minimized the browser, it's not even visible, so they can't even interact with the app.
Yeah.
So we've added APIs in .NET 10 that allow you to pause the circuit, where you can say like, hey, that browser's not visible. Go ahead and pause the circuit on the server. That will actually persist the state, because in those cases, you actually typically still have the connection with the browser. It will persist the state down to the client so that it can be stored client side. So there's no server resource usage for the persistence at all. And then when let's say the user then makes the browser visible, or they start using the app again, clicking on things, then you can resume that circuit from its persisted state. And that helps with scalability concerns, where you basically can free up those server resources when they're not actually currently being used. So that's another scenario that's enabled by this function.
Is that using protected browser storage?
Yeah. When we store it client side, it will use the protected browser storage mechanisms to make sure that it's not tamperable.
Now, don't we only get 5 megabytes of data in that per URL per user?
So that's why the persistence model is very explicit. Like, you decide what you want to persist, and you need to be cognizant of that. It's not like we'll just magically take all your objects and save it to it to that store. You should think carefully about where you use the new persistent attribute, so that you're only
encrypted, but you only get 5 megabytes, basically. Yeah, I'd rather have the encryption personally. It's good.
Yeah. This also, one other thing about that is, you remember, so we've actually had some support for persistent components for a while. There's this persistent component state service that you can use, and that was in the past, prior to .NET 10, that was used for pre-rendering. Yeah. Like, often in Blazor, you render your components from the server up front, so that you get HTML right into the response immediately. It gets sent to the browser, it gets loaded. But then the components usually have to be rendered again so that they're interactive. Like, you set up the connection to the server so that you have a circuit, so that you can handle button clicks and those types of things. Or you load the Blazor WebAssembly runtime and get things interactive on the client. And that double rendering often caused some problems for people, like particularly if you had components that were loading some state asynchronously, like, you know, when they uninitialized, they went off and like called an API or whatever and did something async. Then you often would have like UI elements that represented while you're in the middle of that async load. Like maybe you have like a loading ... while you're loading the weather forecasts or whatever it is, and then you show the weather forecast. Well, if you did that with pre-rendering, you would often see like, I'm loading the data and then I see the data, but then you got another render where you now back to loading the data a second time when it's rendering interactively, and then you see the data. You get this sort of flicker, and you're also loading that data twice.
And now you have to make decisions. Like the way I've done it in the past is I would just load dummy data in the pre-rendering pass, so that I'm not taking up any valuable time, and then
and just do it only on the interactive render.
Exactly.
Or other people would just turn off pre-rendering and say like, well, I'm not going to bother with pre-rendering because it's too annoying.
And that's maybe a problem if you want to take advantage of search engine optimization. So that's one of the only reasons that I can see that you'd want to use pre-rendering. I mean, if you're doing something that an internal application and somebody has to wait 5 seconds for the homepage to load, who cares, right? But if you want Google and all these, and Bing and all these places to index your pages, you have to do pre-rendering.
Yeah. If you wanted to see the HTML, and if you're just trying to improve the perceived load time of the app, getting the HTML right in front of the user really quick can be nice. The old persistent component state APIs were, they were okay. They were a little tedious to use. The persistent declarative persistence model now works with pre-rendering as well. So when you say what state you want to be persisted, when you pre-render, it'll get persisted into the HTML as like basically as an HTML comment is how the data gets stored in that case. But it's the same declarative model. So that's the
and all you really have to do is just check to see if it's there, and if it isn't there, you load it, and if it is there, it's been saved and restored, and you don't have to worry about it.
Exactly. Yeah, that's the pattern.
Very cool. Diagnostics and observability, like Blazor server tracing, that kind of stuff.
So we added a whole bunch of additional new metrics to Blazor particularly for server side diagnostics. So like getting metrics for like when the pages get visited, for like how long your components are taking to apply render diffs. So you can get some metrics on like how fast your components are rendering. There's a whole bunch of data you can now get about what's happening in Blazor from the server just using counters and metrics. We also fixed up the Blazor server activity tracing. Like one of the things that was a little annoying about Blazor server when you would look at traces is you'd have this one big long activity for the connection, for basically the WebSocket connection, right? And then it was very hard to sort of get a feel for like, well, if they're navigating around the app, like it's all kind of nested in this giant activity. We cleaned that all up. So now you see like page navigations within your Blazor server app now show up just like they kind of look like, almost like another request reply episode, except they're done with relationships to the appropriate activity, so you can still trace it back to the parent circuit. So the metrics and tracing for Blazor server apps is much cleaner in 10 and much more useful. There's also now diagnostic tools for Blazor WebAssembly apps. Like sometimes we would get customers that would come to us and ask for help with diagnosing performance issues or memory issues. They're like, we're concerned we've got maybe a memory leak here, but we don't know. How do we diagnose that in our Blazor WebAssembly app? We didn't really have tools to help you do that prior to .NET 10. Now we have APIs where you can collect like CPU sample-based performance traces. You can collect low-level runtime metrics from the Blazor WebAssembly runtime, from the .NET WebAssembly runtime, and you can also collect memory dumps. And you can just analyze those using the standard set of Visual Studio and .NET tooling. So you got a lot more visibility into what your apps are doing and ways that you can troubleshoot some of those trickier problems that might be happening in your apps.
How about this? Is there any situation in which, and just being totally honest here, that you might not need to upgrade to .NET 10 from 9 or a previous version?
Not need to? I mean,
when
if
it
you
matters
just don't
less.
Like performance wins and you don't like new features,
I know,
like,
you're such a salesman.
No one's going to force you to do it, other than eventually .NET 9 will go out of support. But there is
that's a good reason right there, that it's long-term support, .NET 10.
There was actually a lot of people, I don't think have heard this, but there was a support policy change for standard term support releases that made them actually slightly longer. So they're now a 2-year support window instead of a 18-month support window, which is nice. So they kind of line up better with the LTS releases that way. So you get a little bit of a longer window before you really do need to do it, I would say, in order to stay within support. But yeah, I mean, the main reason to upgrade is because why not? Like new C# feature, like it's not just Blazor, like all the things in the lowest parts of the platform. If you want C# 14, if you want all the new like access to post-quantum cryptography, file-based applications got added in .NET 10. Like there's just tons of stuff across the platform that you get access to.
Yeah, that's cool. I mean, I suppose if you have a static application that doesn't have any interactivity and it works fine in HTML, you probably aren't going to be using Blazor anyway. So, but you know, if you want all those great features that Blazor has, you should be using .NET 10.
And upgrading should be pretty easy. If it's not, let us know, because we're trying to make it as easy as possible. The number of breaking changes is kept to an absolute minimum, and we have pretty great tooling now to help you with the upgrades.
All right, so I'm going through the what's new in ASP.NET Core and .NET 10 in the Blazor section. There's some new updated Blazor web app security samples that are very interesting. Can we talk about those?
Yeah, those samples are showing best practices for doing organizational based authentication. Like if you want to authenticate with Microsoft Entra ID. And we've updated some samples to show you the appropriate ways to do that. We've actually also recently shipped a new scaffolder for the .NET Scaffold tool that can add Entra ID authentication to your Blazor web apps. That's been kind of a missing gap in our tooling experience, where like before you used to have like a checkbox. You say, just add me Azure AD auth is what it used to be called, right? Before it became Microsoft Entra. Now it's Microsoft Entra. Microsoft Identity Platform, I think, is the name.
It seems like every version of .NET, we had a new way to do authentication with different classes and things. So it's nice to see that stuff solidify. And I think this was in .NET 9, right? That you guys, all of those scaffolded pages are now not server-side, but they became Blazor components, Blazor pages. So they run client side.
And Blazor can render those pages server-side. Like Blazor has static server-side rendering support now as well. Like if very similar to how like a Razor page or an MVC view gets rendered, you can have a Blazor page that's just routable on your server that you route a request to, and it just renders HTML and it's done. It's not stateful. Doesn't involve downloading a WebAssembly runtime. You're just rendering HTML using Blazor components, and then you can add interactivity to those pages wherever it's appropriate. You can use the render mode functionality that got added in .NET 8 to light up components with interactive contexts.
There's some new stuff in the quick grid. I see this row class parameter applies a style sheet class. I mean, doesn't seem like a big deal, but that's very cool when you can do that.
Little quality of life improvements.
That's right.
Every release, we try to go through what people are telling us on GitHub and our issues to see where are people, giving the +1 reactions on the main post on the GitHub issues. We look at those a lot. We look at what people are commenting on, and we try to address the sort of top areas of pain or top just feature gaps that should be filled. That was a major theme for .NET 10 is let's just clean up a bunch of the stuff that it's kind of annoying for people or just obvious holes in functionality.
I like the way you put it.
This was a very simple feature to be
quality
able to
quality of life feature. It's really good. It's very good. So, just make your life a little bit easier.
Try and delight our users.
And you do. Static apps, static web assets. This is new in .NET 10. Right?
Yeah, so we did a bunch of this work in 9, right? Like in .NET 9, we introduced a really completely new model for dealing with static files in ASP.NET Core. It's not really Blazor specific, where the static files in your app get detected at build time. And we identify them, and then we pre-process them by fingerprinting them with a unique hash based on their content, and also pre-compressing them at build time so that they're as small as they can be. And then when you are running your ASP.NET Core application, those files actually get surfaced as proper routable endpoints. Like they're not just files on disk that we're doing, path concatenation effectively in order to go to load the file off of disk. They're now actual routable endpoints in the routing system, which means all the routing aware features like authorization policies and authentication, those types of things now work properly with those static web assets. So it was much more optimized and also much more feature rich. There are a few files in Blazor that are kind of special, like the Blazor framework files, like blazor.server.js or blazorweb.js. They were actually in .NET 9 tucked as like assembly resources, like in the assemblies, and we had special framework support for pulling those files out so that you had access to them in your applications. In .NET 10, we've restructured how those files are handled so that they're just normal static web assets like everything else. They get pulled in. They still get pulled in when you install the framework and the NuGet packages. So you don't have to go download them from anywhere, but they now get the same optimizations that you would have expected for all your other static web assets. So they're getting fingerprinted, they're getting pre-compressed. This also helps with some problems that we saw where there was actually an issue, I can't remember if it was .NET 8 or .NET 9, where if there was a breaking change between the contract with those framework files and how the runtime worked, you might end up with a cached version of .NET runtime.js or something like that was from an older .NET version than the one you're actually loading, and then would then break. And because it was the same file name with every release, there wasn't a really good way to address that, and that was bad. So now they actually get proper, unique fingerprinted file names, so that you always make sure that you're running on the right version of those files for the version of .NET that you've actually deployed.
Yeah, I love that. All right, so the Reconnection UI component, which we learned, I think that was a .NET 9 thing, right? And now it's added to the web app project template?
Yeah, so you've always been able to customize the Reconnection UI, like that white screen of death that you were describing beforehand. We that screen can pop up when the user gets in the disconnected state, and you could change it to align with your app styling and so forth. We decided actually let's just put that code directly in the template so people have access to it, so they can. It's much easier for them to customize that component. So it's literally just the reconnect modal.razor file now in the .NET 10 version of the Blazor web app template. It also includes the customizations for adjusting the UI that happens when you're dealing with persistent component state. Like you might get into situations where you want to load persistent state from the server, and there's some UI affordances for giving user experiences around that, and so that's also encapsulated in that component as well.
Okay, yeah, that's great. Just really cool. I love this quality of life feature. Ignore the query string and fragment when using navlink match all. That navlink match all is a feature that seems to me most developers, it just goes out in one ear and out the other. I don't think we really understand what that means.
Okay, yeah. So I mean, navlink is a fairly simple component. It's literally just an anchor tag, right? It's an anchor tag that adds a class to the anchor tag, depending on whether the URL matches the URL of the anchor tag or not. So this is used in the purple nav menu that you see in the default Blazor template. When you have that little pill that kind of goes around it when you're on that page, that's what navlink handles for you. And you can change the matching behavior for when it adds that class. You can do it it has to be the specific path, only this one can match, or you can say it can be all in terms of, I believe, in terms of the rest of the path, that whether it has to explicitly match or not. And there was an annoying case where it would take into account things like query string and fragment parameters, which often you didn't want.
Yeah,
so now there's a behavior that we can say
not really part of the route.
Match for all for query string and fragments as well. Well, actually, I think by default it normally won't look at those because they're usually not relevant. And then there's a switch to say if you want it to do that or not.
There's some more stuff in QuickGrid here, close QuickGrid column options. Now you can close the QuickGrid column options UI using the new hide column option async options.
Yeah, this is a simple feature. There's when you have QuickGrid, you can put a little a UI widget on each column header.
Yep.
If you wanted to have a thing where you can say sort, often is a little filter, you put a text box in there because you want to filter the rows by some values within that column. In order to get that little widget to disappear, Before you had to like explicitly click off of it. Now there's an API you can just call to say like, please hide that for me, so you don't see it anymore. Just a small quality of life improvement for that one.
Yeah. HTTP client response streaming enabled by default.
Yep, we just turned this on for the, under the covers, HTTP client in a Blazor WebAssembly app is calling into the fetch APIs. And in order to enable response streaming with the fetch APIs, before you had to do some configuration in order to get that behavior. We decided to just go ahead and turn that on and make that be the default
right, because if you don't use it, there's no problem. Okay, so client-side fingerprinting, is that worth mentioning, or?
So that's similar to what we talked about before.
You talked about that with the static web app sets.
Yeah, where the Blazor framework files now get fingerprinted. In some cases, you need to refer to those files. Like you actually need to load the Blazor framework script. And so there are cases where Blazor can handle that for you. Like we have APIs on the server where we'll resolve the sort of friendly path to the file name to the actual fingerprinted file name. In the case of like a standalone Blazor WebAssembly app where you don't really have a server piece and it's all just being downloaded to the client run client side, we have some build steps that can replace certain placeholders in the file names with the actual fingerprinted name, so you get the right one when the app actually loads.
That's cool. Some new stuff in JavaScript interop.
Yeah, easier ways to call. You can call constructors. You can deal with properties. Just some nice conveniences when you want to call into some JavaScript code and you don't want to have to like a lot of times with JavaScript interop in Blazor, you had to write a JavaScript method that kind of wrapped the thing that you wanted to call. Like if you wanted to call a constructor, or if you wanted to call a property, you had to create a method for that. That was really annoying. In 10, we just give you the C# methods that will do that for you.
And I always found like the templates for the different types of things that did JavaScript interop would sometimes do them in a different way, which is cool because every project is different, and sometimes you have existing TypeScript or JavaScript files that you have to deal with, and sometimes you're creating your own, and sometimes they're out there and you need to completely contain them in a component. So yeah, it's really good to see all these flexible options.
Just makes it easier to consume JavaScript code when you need to.
Yeah.
Simpler patterns.
Navigation.
Yeah. Okay. So one of the big things we did in 10 for Blazor is proper handling of not found responses. Like particularly if you're doing like static server-side rendering and you want to return like a normal 404 response from your Blazor application, there wasn't really a good way to do that prior to .NET 10. And if you wanted to customize that content, also again, there was not a great way to do that. So we added a feature to the Blazor router now where you can have a proper not found page, which is just another page in your application that will get rendered whenever you're doing a 404 response. And there's an API now in Navigation Manager where you can say, I'd like to issue a not found response right now. So you just say navigation manager.notfound when you're in that situation. And that will work consistently across all the different render modes. So even if you're in an interactive render mode like Blazor Server or Blazor WebAssembly, it will still render the proper not found component.
And does that also work for static SSR rendering?
Yeah. In fact, that's one of the main cases where you would use it.
Yeah.
You're on a page and someone's trying to browse to a specific product, product entry in the catalog, but that product entry doesn't exist, and so you go to the database and you say, oh, wait, it's not there, and you want to return a not found. There wasn't a great way to do that prior to .NET 10, and now there's first-class APIs and support for that. One thing that I also really like in 10 that's not specific to Blazor itself, but it's implemented using Blazor, is the new Passkey support. So if you're doing authentication using ASP.NET Core Identity, ASP.NET Core Identity gives you a password store and a way to manage user accounts and their user data. But modern web applications actually are moving towards a passwordless model, like using web authentication patterns, where the credential you present to the app is no longer a password that the user has. It's a proper cryptographically generated key that they've stored in some authenticator app. Like maybe they have a UBI key, or using you could use Windows and Edge to store your passkeys, or you can use whatever authentication app you prefer. And the nice thing about that then is that key gets associated with that specific web application, that specific origin. So it's very hard to phish it. And it's cryptographically secure, and the user doesn't have to remember passwords for every site. So that Passkey support is now built into the default Blazor Identity UI that we provide in our templates. It's will get scaffolded if you use the Blazor Identity Scaffolder, and then all the APIs that support that are now part of ASP.NET Core Identity.
One of the problems I've seen with passkeys is that everybody's got a different, passkey manager and stuff. So there doesn't seem to be any standard. Can your system support different clients? Like if I'm using Microsoft Authenticator and that guy's using Bing and that guy's using Windows and another one's using a YubiKey, can they all work together?
Yeah, because that interaction between the Authenticator app and the web application is actually standardized. So you use whatever Authenticator app you want. Like if you want to use one of your password managers most of the password managers operate as passkey stores, or if you just want to use Windows itself. When I demo this, I often just use Windows because it's really convenient. But if you want to use like I don't know, Bitwarden or whatever as your passkey store, then so that it flows across devices and different platforms, you can totally do that too. How the Authenticator app interacts with the browser to provide the passkey is a spec, is a standard protocol.
Okay, form validation, new stuff.
Yeah, so validation got a whole revamp in 10, not just for Blazor, but across ASP.NET Core. So there's a new validation subsystem that we added so that we can, you now support validation for minimal APIs. Like if you want to do model binding and validate the bound values, you can now do that from your minimal APIs. That's a first-class feature. And we took that same validation system and plugged it into Blazor, which is great for doing like when you want to do full object graph validation of what gets form posted. We didn't have really first-class support for that in Blazor. We would only validate the top-level properties because that's just sort of the default behavior of the system component model validation logic. But if you want to dive down deep into the object, you need to have something that walks the graph and validates at each layer. That's what the new validation system does, and you just get that for free in .NET 10 if you just make that one call to add validation. If you add the validation services, the data annotations validator in Blazor will pick that up and now do full object graph validation. I think we had at one point a different component, like an object graph data annotations validator component that we shipped in preview for a while, that a lot of people were still using because we didn't have any other solution for doing full object graph validation. If you're still using that component, you could please remove it because it was never actually even shipped as a stable version. It was always still in preview. And now we have built-in support for it right in the framework. Just make that call to add validation and you're good to go. Another thing that I think is, it's not specific to Blazor, but it really helps the Blazor development experience, is we added significantly improved support for automated browser testing of ASP.NET Core web applications. We've had this, what's it called? Web application factory type that we've shipped with the framework for a while. And what it does is it gives you a way to basically load an ASP.NET Core app in memory, and then you can ask for an HTTP client, and you can then use that HTTP client to send requests to the ASP.NET Core app all while it's in memory. Like you don't have to open a port or a network connection in order to do that. That works great for like testing APIs. Like if you have some API points you just want to send some requests to, and you don't want to deal with the network, but you still want to exercise the full pipeline, then Web Application Factory worked really well. It didn't work really well if you wanted to, if you had a web app where you really needed the web platform there. Like you needed the browser in order to fully exercise the functionality. In some cases, you could kind of hack around it by using the HTTP client to fake form posts and then parse the HTML that came back using HTML parsing libraries.
That's a lot of work.
It's really clunky. So what you can do now in 10 is you can, instead of just using the in-memory hosting of the app, you can ask it, say, please just use Kestrel. I just want you to use Kestrel.
Okay.
And then it will actually open a port and sort of host things locally. That gives you still all the hooks where you can go in and stub out services and, things that you want to mock out. The Web Application Factory has a bunch of hooks that lets you do that. But then you can point a normal automated browsing test framework like Playwright. At the Web Application Factory generated endpoint and test the whole system end to end. So it's a much better end to end automated browser testing solution.
How's Hot Reload working for you these days?
Oh, I'm glad. I'm glad you mentioned that. So hot reload so we just shipped Visual Studio 2026, right?
Yeah, it's much better in there. Yeah.
And particularly if you're on the Insider version, that's where we've now turned on by default this feature where the Razor language server and the C# language server are now co-hosted. We call this co-hosting of the Razor language server, and that dramatically improves the performance and also simplifies the system a lot. So it improves the reliability of hot reload.
Yeah, Dustin told us about this on .NET Rocks and blown away.
Yeah, so like I think before, like the one demo that I've done is if you take a large project like Mud Blazor is a very popular Blazor component library, a fairly large sample application that demonstrates all their components. Like before, if you opened up that project and tried to do a hot reload with Visual Studio, it took like 45 seconds, like some ridiculous, almost a minute to hot reload a change, which is not very hot. It's more cold reload. With the new system, it's like a couple seconds, and you can hot reload changes into that entire application. So it's getting much better, and we also just continue to improve on the the overall development experience, the reliability of it, and the number of changes that are supported by the runtime, like the types of things that you can do that actually can be hot reloaded into the application in a valid way.
Input hidden. I was looking at this a component to handle hidden input fields and forms, and I'm thinking to myself, why do you need a component for that? Is it just because it's inside an edit form that you can't just do a hidden input field?
Well, if you want to bind it to, like, because you can see in the example, well, I guess this is just we're looking at this.
I'll show. No, we're looking at it on the screen.
Okay, so with an edit form, you often have a model, and that model has properties and things that you're actually binding the individual inputs to. If one of those properties, like on your model, represents the thing that you want to be the hidden field that you're sending back and forth to the server, but isn't actually visible to the user, then that's what the input hidden component helps you with. It's not a
quality of life.
Yeah, it's one of those small quality of life things that people were requesting. Like, why don't you just have this? And in like the world of AI, also, like a lot of these features are also really just easy to add. Like a lot of things that are on our backlog that we would be like, that's not super important. It would be nice, but we have all these other things we really like to do. Maybe we can just assign it to GitHub Copilot coding agent, and it'll just do it for us. And it does, and that's just fantastic. So
are you guys using that? Are you using that in the .NET repo and in the Blazor repo? Yeah.
Tons. Yes. And encourage everyone to do so as well. Like, I mean, we did have to do some work in the repo to make it GitHub Copilot friendly, like adding appropriate instructions files and like, things that gave the coding agent context that's kind of specific to what it means to be a Blazor framework developer or an ASP.NET Core framework developer, that type of thing. But once we've laid that infrastructure, that's really just opened up the floodgates for really burning down our backlogs much quicker, enabling the agent to quickly develop and also test things. Just use the Playwright MCP integration so that it can, after it's done the changes, it can then just fire up a Blazor app that tests the functionality and exercise the app. All that stuff can just be done by the coding agent, which is just amazing. Like it's really cool. Fantastic.
It's really cool. That, and with the new C# 14 features you were talking about, it's just like it's blazing. It's blazing hot.
Yeah.
Anything we missed that you want to call out?
No.
Okay.
I think we got it. I think we got the big ones.
All right, great.
I mean, there's obviously other things besides this, just Blazor, that you should definitely take a look at. You mentioned C# 14, like the new extension members and the field keyword, null conditioned assignment. Those are all, really nice language additions that they did. If you haven't played around with file-based apps, that's also a lot of fun, where you just have a C# file sitting on disk, and then you just like .NET run a C# file. Like that's pretty cool. There were some really neat things done in the SDK to make it much easier to create .NET tools that you could easily run. Like in the Node world, like the JavaScript world, you could just like npx like a Node package, right? And that was a very common pattern for like MCP servers, honestly, for when you're trying to extend like AI coding agents. In .NET now, we have a similar mechanism where you can just basically point the .NET at a NuGet package and run that as a tool. It makes it much more convenient way to run .NET implementations of MCP servers. There's a ton of great stuff. So definitely, if you haven't tried .NET 10, haven't upgraded yet, strongly encourage you to do so.
Absolutely. Dan, thanks for coming back on Blazor Train, giving us the 411 on Blazor and .NET 10.
Thanks for having me.
All right. Now back to you in the studio, Carl. You know, if you've been riding this train as long as I have, I'm sure you picked up a lot of good habits. And now that you know the skinny on .NET 10, well, you know what you need to do. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blazor Train!